Welcome to Unit 8. Day 1 is going to deal with the Pascal's triangle and something called the Binomial Theorem, where we take something like a plus b and raise it to a power like 4 or 5, something higher than squared. Pascal's triangle is going to use something that we use at the end of Unit 6, the combination key off your calculator. So Pascal's triangle is a special pattern of numbers. It's going to be a triangular arrangement. The first number in each row, well, the sub number, it starts with a 1 on the top row. Each new row starts with a 1 and ends with a 1, and the middle terms comes from adding the two diagonals to above it. And I'm going to show a quick little video to show how it goes, and then we're actually going to do it by hand. And here we go. We're going to do Pascal's triangle as soon as it plays. Starts with a 1, a 1, 1, get the ones at the beginning and end, and the middle one comes from the stuff above it. Over and over and over again. You see a nice triangle pattern here. You can see you're getting more and more terms, so on and so forth, but the new term always comes from the two diagonal terms above it. So as you can see, I started with the top row. It's actually called row 0. We'll talk about that in a minute. The next row goes 1, 1. And then the next row after that, I'm going to start with a 1. Then I add these two terms above it. And I get a 2 in the center. And then the last one is a 1. Now when I do the next row, I'm going to start with a 1. I'm going to add these two terms. I get a 3. I'm going to add these two terms above it. I get a 3 again. And I end with a 1. Again, I start with a 1. I add these two terms. I get a 4. I add these two terms. I get a 6. I add these two terms. I get a 4. And it ends with a 1. And then finally, start with a 1. Add these two terms. 5, 10, 10, 5, and finally ends with a 1. Those are the first 5 rows of Pascal's triangle. So let's see what we see. How many terms are in row 3? Well, in row 3, I see I have 4 terms. In row 4, I see I have 5 terms. So I can make the general statement that in row n, I'm going to have n plus 1 terms. What is the second term and the second last term in every row? Well, let's see. In row 3, the second term is 3, and the second last term is 3. In row 5, the second term is 5, the second last term is 5. So it looks like it's just the row number, whatever the row number is. Do we see any symmetry in this triangle? Well, if I go right down the middle of this triangle, you can see that there's symmetry down the middle. That the left half and the right half have exactly the same numbers, but in reverse order. So what is the sum of each row? Well, let's look at the row 0. The sum is equal to, let's see, we'll pull this over. The sum is equal to, in row 0 is 1, in row 1 is equal to 2, in row 2 is equal to 4, 8, 16, and 32. So is there a pattern? Well, let's see. Is there a pattern to this? Well, I believe if you look really closely, because we start with row 0, the sum is equal to 2 raised to the n power, where n is equal to the row number. So this is 2 to the 0, to the first, squared, to the third, to the fourth, to the fifth. So the sum is equal to 2 to the n, where n is equal to the row number. And we're going to call the row number n many times today. So instead of calculating the whole triangle by hand, we're going to use that special key that we use in Unit 6, the combination key. If you remember the combination key, the NCR key, this is going to help me figure out any row for Pascal's triangle. It's easy to do the first couple by hand, But if I wanted to row 8 of Pascal's triangle, that would take a while to do by hand. I'm going to use the calculator to figure out, and it's all based on this combination key. So when I do row 0, I know it starts with 1, but it's really 0C0. And when I do row 4, I have to do 4C0 all the way to 4C4. And if I put these in the calculator, you're going to see on the calculator that I do get the numbers 1, 4, 6, 4, 1 when I do these individually. And I also have the symmetry that we had before when we did Unit 6 with combination, that NC0 is the same as NCN, and that NC1 was really equal to NCN minus 1, and so on. Remember when we talked about combinations and putting toppings on a pizza or a burger, that we had this whole symmetry going on. And this is going to be very important. So the whole idea is that I'm going to be able to do Pascal's triangle any row using the calculator. I can do it in one step on the calculator. I'm going to use some special keys. I'm going to have to use the curly bracket keys, which are above the parentheses, and the comma key, which is above the 7 key. And I could type this into my calculator. So here's what would be 5th rows of Pascal's triangle. I could type this into the calculator all in one step. But we have to make sure that when we ever do this, that it's going to be whatever number n we want, whatever row we want, and I have to start with 0 and end with the end. Make sure you start with 0. And I'm going to show on the calculator how to do the 5th row all in one step. So I got to hit clear out calculator. I'm going to go change my mode. It doesn't really matter so much, but let's be in degree mode and function mode. It won't really matter for this unit if you're in parametric or polar, but you know, if you take a SAT, it's probably best to be in there. So to do this, to do the 5th row, I'm going to do 5, math key, move it over the probability, choose the NCR key, and now this is what you have to do. I could do all at one time instead of doing 0, 1, 2, 3, 4, 5 individually. I have to take the curly brackets, so I have to hit the 2nd key. The curly brackets opening is above the parentheses, and I have to do 0, comma 1, comma 2, comma 3, comma 4, comma 5. Oops. As you see, I hit a 7 instead of a comma. Comma 5. And you don't even have to close the brackets at the end if you don't want to. The calculator doesn't care. I hit enter, and look at that. I get the whole 5th row all at one time. It's very, very nice. So there's another video here if you want to watch it. I'm not going to click on it. You can watch it on your own. But sometimes instead of using the NCR notation, we use this notation right here. It is the same, such as 5C2 is the same as parentheses 5 over 2. It means the same thing. It's just another way to write it. So why do we use Pascal's triangle? Well, let's see if it's helpful for this pattern. Let's do a plus b to the n or x plus y to the n. It's all the same thing. So a plus y to the 0 power, I hope everyone knows that that is equal to 1. And a plus y to the first is really just x plus y. I'm spreading it out on purpose. And then x plus y squared, or a plus b squared, I hope you know it's going to be x squared plus 2xy plus y squared. You know, we've done x plus h squared is the same thing. Well, let's really see if there's a pattern here. Let's put down the coefficients. I'm going to put a lot of coefficients. Here's a 1. There's a 1 here. There's a 1 here. There's a 1 here. There's a 2 here. There's a 1 here. I look at these coefficients and I said, wow, these coefficients is just Pascal's triangle. The other thing I notice are the exponents on here. This is 1x to the first, 1y to the first, x squared, x to the first, y to the first, and y squared. And we're going to talk about what that means when we do Pascal's triangle. What Pascal's triangle is going to help me expand a plus b to the 5th, x plus y to the 7th, and so on and so forth. So the numbers that I get from the nth row of Pascal triangles are the coefficients when I do a plus b or x plus y to the n. We're always going to start with x to the n, y to the 0, or really just x to the n. Each new term, my exponent x will go down 1, my exponent on y will go up 1. I'm going to end with x sub 0, y sub n, or really just y to the n. And the sum of each exponent on each term is going to equal whatever n is. If you notice here, this is n is 2, and these exponents add up to 2. So I need the coefficients from Pascal's triangle. Because a plus b or x plus y is called a binomial, 2 terms, and we're raising it to the end, it's called binomial theorem or expanding a binomial. Just using a sigma notation, knowing that I'm taking the sum of each term. I'm having all these terms together, so it's a sigma. Don't get caught up in this notation. We're going to do this by hand. So this is x plus y to the third, so I'm going to use row 3 of Pascal's triangle, so I have to do 3, C, 0, 1, 2, 3 on my calculator. You get the third row of Pascal's triangle, and when I do that, my third row is 1, 3, 3, 1. Or you can look on the front page. So what does that mean? I'm going to get it. It's going to be 1x to the third, y to the 0. I'm not going to write that down. Plus 3x squared y to the first, plus 3x to the first y squared, plus 1 y to the third. So x plus y raised to the third power is really what I did in red. The coefficients came from Pascal's triangle. The sum of the exponent of each term is equal to n, in this case 3. And how many terms did I have? I'm going to always have one more than the row, and this was, or the exponent of 3, so this, for this example, was 4. But I don't really need to write the ones, so I would really write this as x to the third plus 3x squared y plus 3xy squared plus y to the third, because I don't really need all those ones. So I could do that longhand and multiply it all out and use a piece of paper, but I could just use Pascal's triangle. So this is a plus b to the 6th. I'm going to do row 6 on my calculator, and my row 6 on my calculator are the numbers 1, 6, 15, 20, 15, 6, 1. Begins with 1, ends with 1. Second term is always the row, which is 6. And because it's 6, there should be 7 terms, and there are 7 terms. And I can write it out as 1, a to the 6th, plus 6, a goes down to the 5th. Now I have b to the 1st, plus 15, a to the 4th, goes down by 1, b squared goes up by 1, plus 20, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6, a, b to the 5th, plus 1, b to the 6th, and that is my final result. If you notice, those numbers, those coefficients are from, in red, Pascal's triangle, and the sum of the exponents for every single term is equal to 6 because we did row 6. And there's 7 terms because I did the 6th row. So, a plus b to the 5th, I have to do the 5th row, 1, 5, 10, 10, 5, 1, and I'm going to get 1, a to the 5th, plus 5, a 4, b 1, plus 10, a3, b2, plus 10, a2, b3, plus 5, a to the 1st, b to the 4th, plus 1, b to the 5th, and that's my final result. So my question is, how does a minus b to the 5th be different? Well, I'm kind of going to use that negative b idea, and what really happens, it just alternates positive and negative signs. So the first term will be positive, and then we're going to, well, and then we'll write this out, and we're going to see a nice little pattern. So I'm going to take all this, and every other term I'm going to make negative. The first term is positive. A to the 5th minus 5a fourth b plus 10 a cubed b squared minus 10 a squared b cubed plus 5 a b to the 4th plus, minus b to the 5th. That's my final result. And the one thing I do see here is that when I have b raised to an odd number, I have a negative sign. Look at that. B raised to the 1st, b raised to the 3rd, b raised to the 5th. They had odd coefficients, and b raised to an even had a plus sign. So how can I use a plus b to the 5th and now do x plus 2 to the 5th? Well, the one thing I can do, I can substitute every time I see a letter A, I'm going to put an x. And every time I see a letter B, I could put in a number 2. So when I sub all that stuff in there, instead of a to the 5th, I'm going to get parentheses x to the 5th plus 5 x to the 4th times 2 plus 10 x to the 3rd, 2 squared plus 10 x squared, 2 to the 3rd plus 5x 2 to the 4th plus 2 to the 5th. And now I'm going to have to do some multiplication. I'm going to have to clean up all this algebra. I can't leave it that way. I got to clean it all up. So what I see here, after I multiply everything out, 5x parentheses to the 4th 2 becomes 5x to the 4th times 2, 10x cubed, 2 to the 4th, 2 to the 2nd is 4, and so on and so forth. I got to multiply all this stuff out, and I get x to the 5th plus 10x to the 4th plus 40x to the 3rd plus 80x squared plus 80x plus 32, and I get a nice clean x plus 2 to the 5th turns into this. I could do it longhand, or I could just do it this way. It's much easier doing it this way. A couple more videos if you want to watch to see how to expand a binomial. I'm going to do x cubed plus 2 to the 3rd. Row 3, which I've done so many times, is 1, 3, 3, 1. I'm going to do a plus b to the 3rd. And then I'm going to sub in a is equal to x squared, b is equal to 2 for this whole problem. I substituted in all my a's and b's. I mean x squared and 2's for the a's and b's. And I'm going to multiply it out. And then I'm going to multiply each of these terms all together. X to the 6th plus 6x to the 4th plus 12x squared plus 8, which is my final result. And because it was row 3, I better have 4 terms. Now how's it going to change when I make this a minus sign? Oh, well, all I got to do is alternate signs. X to the 6th is positive, minus 6x to the 4th plus 12x squared minus 8. And that's how a squared minus 2 to the 3rd is different than a squared plus 2 raised to the 3rd. So 2x plus 3 raised to the 4th, it's going to be row 4. 1, 4, 6, 4, 1. So I'm going to write it with a's and b's to begin with. My next step, I'm going to substitute in a equals 2x and b equals 3, and I'm going to use parentheses. It is really important to use parentheses when you put 2x in for a and 3 in for b. So notice I put all that in with parentheses, and now I'm going to determine what each term is going to give me when I put this all together. And now that I've gotten rid of the parentheses, I'm going to do each of these terms and multiply them together. 16x to the 4th plus 96x cubed plus 216x squared plus another 216x plus 81, and this is your final result. I'm going to do row 5, since it's raised to the 5th, 1, 5, 10, 10, 5, 1. Those are my coefficients. I'm going to use a's and b's first to do all this. Don't forget the subtraction in between the two terms. That means you're going to alternate side for positive, negative, positive, negative. Now I'm going to go ahead and substitute in a 3x in for a, 2y in for b, putting parentheses around everything. Now that I put everything in for a's and b's, I'm going to multiply each of these terms out. Well, if it's the fifth row, I better have my 6 terms here. So you see I multiplied everything out with the parentheses, and I'm going to clean it all up, multiply the whole thing out, and you can see we're going to get some bigger numbers because of what we were doing here. It's okay. And if you pay real close attention, you notice that all the x's and y's better have exponents that add up to 5. Because we did the fifth row, so the exponents are adding up to 5, and I have 6 terms.